things before we get too far in. You may or may not be aware, some of us were just aware when you walked in, that conferences are coming up. We are getting close to the midterms from this trimester. I want you to know that conferences happen tomorrow night and next Wednesday. Okay? You may or may not be aware that we only have a 4-day week this week. We only have a 4-day week next week. We have a long weekend. And the reason for that is because I have the opportunity to be here to talk to your parents from 4:15 to 7:45 in the commons, okay? Now, I know that some people have anxiety when it comes to parent-teacher conferences, but I want to let you know that I love them. I love talking to your parents, and I will say great things about you, okay? I have no one in here that I would say bad stuff about. I would really, really encourage you to send your parents my way, okay? Number one, friends, could you be quiet so you're listening and I know that I have to talk over you? Thanks. Number one, because then they'll come home and say, wow, you're so cool, right? Because I'll talk you up. Number two, because we have this funny grading system, I want to make sure that your parents understand the way that everything's working, and we are going to talk about it today as well, but I just want to make sure that we're all on the same page, okay? And number three, if you need a third reason to encourage your parents to come to conferences, I love conferences so much that I institute a class competition vis-a-vis conferences. So the class that has the highest percentage of parents coming to conferences will receive something fabulous. Probably, well, certainly not grade related, because there's no standard that says my parents come to conferences. But there's rich food out there that one might choose or watch or something, and we'll make something happen. So, for one of those three reasons or something else, send your parents to conferences. Come with them. Then you can hear all the nice things that I'll say about you. Okay? Those are all good things. Okay, today we are going to do a warm-up problem. It's going to take much of our time because it's good physics conversation. After that, we're going to start processing your lab data. If you were gone on Friday, you will not collect data, but you will need to do the design portion. So come in and see me sometime, like a 10 or 15 minute window that you have during Liberty Time, a free period before or after school. Any of those times work. And then the last 10 minutes today, we'll talk about grades a little bit, okay? I also want to let you know this is a lot of logistics, but I want to make sure you're hearing this. So please, in the back, stop talking. Thank you so much. Okay? Quiz 1A retakes. I mentioned this last week, and then we didn't really do anything about it because we were so busy with homecoming and all of that. But Quiz 1 retakes are available anytime this week. So if you would like to make up, or you would like to retake that stuff, you'll need to meet with me ahead of time and have your homework completed so that you can do it. But that's absolutely fine. Okay? And then also a friendly reminder that the 1B quiz is tomorrow. Okay? Questions that you have right now for me? Okay. Before we get too far into things, I want to introduce our guest who will be here. She's going to introduce herself. Go ahead.
Hi, so I'm Ms. Gerbil. I'm a student at the University of Iowa getting my master's degree in secondary science and mathematics education. So in May, I'll be a science and math high school teacher. And so I'm going to be here through the rest of the semester or until you winter break. And I'm going to be learning a lot from you guys and hopefully getting to know you and helping out with some physics. So thank you so much for having me.
Yay! The other really nice thing is that, like when you guys are working and talking and that sort of thing, there's only one of me and lots of questions that you have. But she knows her physics too, right? So she can come around and she might just ask you questions like, why are you asking me questions? It's so you can be thinking about what you're doing. Because sometimes it's weird, like, I've got this, I know. But then, sometimes questions are a good thing, right? To get your brain working. So now that it's like there's two of us walking around, it's great. Okay? One other thing that I wanted to make sure that we said was that the standards, I wanted to make sure you've seen these standards. You've seen them a couple times. I've mentioned them a couple times, but just in case it's been a long weekend and you've forgotten about what the quiz might be over tomorrow. Okay? 3 standards, that means 3 sections to the quiz. Okay? The first one is I can draw and interpret diagrams to represent the motion of an object moving at a constant acceleration. That's, can you graph stuff and can you interpret graphs? Second one, I can define position, distance, displacement, speed, velocity, and acceleration, and differentiate between them. Okay? Knowing the vocabulary. These kind of go together, but they're going to be 2 separate standards. And then the last one is that I can solve accelerating motion problems. Okay? This one is all of that problem solving that we did last week. There will be at least 2 problems in this standard. You can do both of them graphically, both of them algebraically, or one of each. I don't care, as long as you're doing good physics. Okay? Questions that you have for me about this? Okay, all right, so now I'm going to have you take a look at this warm-up problem. So you may recall from Friday, or you may not, either way, that we dropped some objects off of the balcony about 5 meters above the floor, okay? One of the objects is a tennis ball. I would like for you to draw graphs of the position versus time and velocity versus time, okay? And also describe the motion of that tennis ball as it was falling to the floor, okay? Go ahead and have a conversation, and yeah, we'll regroup in a second. Go, go, go. It seems as though we've got a lot of kind of going on. I'm going to let you know, we just went through those standards, and that first standard, what did it say? I'll look again because I don't remember. But it said, I can draw and interpret diagrams to represent the motion of an object moving with a constant acceleration. What we are doing right now is this. So this is a good assessment of whether or not you're understanding the physics. Now, we haven't really talked about things going up and down yet, and that part is a little new, but the rest of the process, the rest of the way we're thinking is fitting right in here, okay? So stay with me, don't turn your brain off, there's a lot of physics to be learned in the next few minutes, okay? I'm going to start, or I'm going to ask you to start, with the description of motion. So we'll get to the graphs in a minute, but I want to start over here. So some of you weren't here on Friday. I'm imagining that you've got the idea, but I'm going to go ahead and show you. Here's a frog. Frog is similar to a tennis ball or a puppy. Here we go. We're going to watch it. It's not 5 meters, but again, same thing. So take a look here. So I'm going to let the frog go. Okay. So now you've seen the motion. Everybody's seen it. Raise your hand if you can tell me something that I could add to this as a description of motion. Give me some words to describe its motion. Lots of choices. Lots of words to choose from. Charlene, what you got? What's one word you got? Or a little phrase? It's what?
I think it's semi-constant.
What is constant?
The speed.
Okay, so the speed of the object. So you said the speed is constant. Is that what you said?
Yeah.
Okay, so I want to ask, because I want to make sure that we're saying, so what's the velocity right now? Like right when I let go of it? Zero.
So it's
And then, wait, you're changing your stories. What?
wait, no.
I'm not saying you're right or wrong, I just want to know what the speed.
It's increasing.
Is it increasing?
Yeah, as it graph.
As it falls?
Yes.
What do you guys think?
Yes.
Okay, so the speed of the object is, I'm not letting off the hook completely yet, we're not done. Okay, the speed of the object is increasing. And is there a fancy physics word that we can use to describe something where the speed is increasing or changing in general? Look at all these guys who've got your back. Does that make sense? If the speed is increasing or decreasing, friends, if the speed is increasing or decreasing, we can say that the object is accelerating. So if you don't have these things written down, I'd write them down right now, because these are good things to have. Okay? So the speed is increasing, or in this case, it's accelerating. All right. Tell me more. There are lots of different things that you can use to describe the motion of this object. Please don't waste my markers. Please put the markers away right now. Right now, I want your brain with me here, thinking of description words. There's lots more. Who else has got something? What's that? What's it?
The position. I don't know.
No, I'm not saying that you're wrong. I'm just trying to. So it is a very scary word when you're describing all this stuff, right? Because we don't know. So like you're saying there's a positive slope on a graph. Is that what you're saying?
Yeah.
Okay. And why do you say that there's a positive slope?
Because it's going up. I don't know.
Okay.
I don't know.
Okay. I'm gonna let's see what she wants to say, and then I'm gonna come back. Okay. Is that okay? She's like, thanks. And I'm coming back. Yeah.
Well, I was just wondering if the position versus time graph would be like starting up on the y-axis and then going down since you started, like you dropped it from a high point.
Sure. So can I say the change in position is I'm trying to interpret what you're saying into some physicsy words. The change in position, is it?
How you measured it, because if you were saying that, like, where you dropped it from was the starting, like, the origin, then that would be 0 and it would be going up. But if you're saying that the floor is 0 and that you're dropping it from 5, then it would be kind of it would be negative.
Okay, so I'm going to have two kind of scenarios here, so what I kind of hear you saying, is that right? So you either x equals 0 here. Friends, are you with me? We're doing some really good physics thinking right now, okay? So I want you to stay with me so that you understand what's happening. So x equals 0 here, or was he saying, or x equals 0 here, right? So in either case, I've got the tennis ball. So here it is here, or here. So those are kind of two different situations. Two different groups are dropping the tennis ball. Where's it going to go? It's going to go down, right? So it's going to go, I don't know, we could just draw like a little arrow going like this, an arrow going like this. The change in position, is the change in position going to be positive or negative? Is that kind of what you were saying?
Yeah, I'm saying, like, if when that is 0, I mean, I guess they're both going to be negative, just like one, you could write it 2 different ways, and it would kind of mean the same thing.
Sure.
They'll both be negative.
So
one will be like -5,
oops.
And one will start at 5 and go to 0.
Gotcha. So either way, I think I'm just trying to draw some pictures to represent kind of what you're saying. So tell me if I'm doing this wrong. Are you kind of saying that, like, if this is my number line, no matter whether I call height equals 0 here or x equals 0 here, generally we're going to call the up direction positive? Does that make sense to people? That generally up is going to be positive and generally down would be negative? So in either of these cases, regardless of where my x equals 0, my origin is, if it's here or here, does it make sense that my change in position or my displacement is going to be negative? Does that seem okay? Okay? So the value is still going to be -5 either way, but we know that that's going to be negative because it's moving down. We're doing okay? What velocity does it start out at? 0? So it's got an initial velocity of 0. And we said here that the speed of the object is increasing. So at some point here, as it's falling, so the speed, actually if I'm drawing little arrows here, and that's like a speed arrow, that might not exist, but maybe then here it's like this, and then maybe here, like right before it hits the ground, it's like really big, right? Because you said it was increasing. I want you to talk to your tables real quick, and I want to ask, is the velocity here or here, is that a positive velocity or a negative velocity? Can you talk to your table friends real quick? Is it a positive velocity or a negative velocity? Understanding that doesn't mean that you turn your brains off, right? You guys got this. You can do it. Even if it's kind of weird, we're still talking. So quick question, I'm going to go ahead and take a vote here. The velocity as this object is falling, how many of you think it's positive? It's got a positive velocity as it's falling down. Go for it. How many of you think it's negative? Okay, so we've got kind of a split. A few more votes for negative. Why? Talk to me. You had a strong opinion. Go.
If the position is negative, velocity is position over time.
Okay.
There would be negative over time.
So, I'm trying to process what you're saying. Velocity is change in position over time. So if you've got negative, oops, it's frozen, you can't see that. Hold on a second. Let me make sure we're good. Okay. So, velocity is change in position over time. Is it possible, this is good conversation that we had last week too, is it possible for an object to be at a negative position and have a positive velocity? Yeah? Is that possible? You know that big chart we did? So like if this is my origin, remember this way? If I'm back here, am I negative? Yeah, can I have a positive velocity? Where do I go?
Towards
This way, right? So I don't disagree with you, Jimmy, because I think that you're on the right track, but it's not just the position, but it's the what? The displacement. Does that make sense? The displacement is negative. It is negative because if we start here at 0, and then we go negative, we got -4 minus 0 is, right, -4. Or if you have 0 here, you've got 5, and you've got, what, 3 or something like that, right? So you're 3 minus 5, and that's also going to be negative. So you've got a change in position that is negative. Are you with me here, friends? Change in position is negative. If you have a change in position that's negative, that means the velocity has to be negative. Can I write that down real quick and then I'll come right back to you? So the initial velocity is 0, but as the thing falls, the velocity gets more negative. Is it okay for me to say that? Does that seem okay? Because it gets faster and faster and faster, but it's all in the which direction? Or the negative direction? Is that okay? Olivia, did you have something to say?
No, that was
You're just gonna like tie it all up in a nice bow for me? You just stop talking is what I need to do and start learning. All right. Oh, and one other question for you. One more question, and then we'll move on to graphing, because I know that that's what you guys were really excited to do. So I'm sorry that I've been holding you hostage from graphing for so long. Here's my last question for you. You've told me, in fact, that's the first thing you said was that it's accelerating. So my question for you that I want you to talk to your table mates about is the acceleration of that object as it's falling, is the acceleration positive or negative? Okay? Discuss. Go. I can't even this is a great day to be in physics. I have to say. Because there is so much. See, here's the thing, is that at the beginning of the year, as physics students, you don't know very much. And so it's hard to have a conversation. It's kind of like when you have a little, you'll learn this, well, you may know this if you have young siblings, but I have learned this as a parent because I didn't have any younger siblings, that when people are brand new to either life or to physics or to whatever, they're not, they're fun, but it's hard to have a conversation, right? You can't have a conversation with somebody that doesn't know a lot about physics. But now, you guys, you have learned so much already that you have vocabulary to actually put into place this stuff. You're not there yet, you don't have it all figured out, thank you, but you do have enough that we can walk this way. So, the question that I asked you was, there is acceleration, is it positive acceleration or negative acceleration? And I want to take it on again because I think both are valid and interesting ways to think about where we're at. Raise your hand if you think that the acceleration that this ball is experiencing is positive acceleration. Okay. Raise your hand if you think it's negative acceleration. So there's a little bit of both, and then there are some of you that have abstained. All right. Does anybody have any arguments for one or the other? Yeah.
So I said negative because it's not going towards the origin, it's going away from it, and it's also increasing speed. It's accelerating, so it's speeding up. Negative.
Yeah, and can I hold up this little piece of paper to remind everybody that this is here? Friends, you have learned from me, I hope, that the sheets that I hand out to you are not just busy work, right? This sheet, get this one out if you want to write it. This little half sheet that's buffed. I think, did you use this to answer that question? Yes, you did! I love it! And in fact, that's where I was going to go with it too. I'm going to look for that same sheet. Where's it at? There it is. All right, friends. Take a look at this sheet again. Take a look at, oops, it's frozen so you can't see it. Take a look at this sheet. Make sure that you got it in front of you because there's learning that's going to happen from this. Are you ready? So here we go. First of all, we were talking about velocity earlier. So we had positive velocity and negative velocity. And remember, we just had this conversation about positive velocity meaning motion in the upward direction. So I'm going to note that real quick. And you may want to write this on this piece of paper again because this is a living, breathing piece of paper that we need to deal with. So here we go. I'm going to go and put this here. This is like upward motion. Oops, it's free, so you can't see it. Bam. forward motion in our x direction, right, in this direction, is the same as like up in the up and down or vertical direction. Moving backwards, that's really like what? It's like going down. Yeah. And I'm going to go and put this over here too. So over here we've got up, and here we've got down. So my friend Debbie's super smart. Like, I don't want to, like, I'm not trying to, like, discount that. But I asked her, I was like, did you use that sheet to figure out? She's like, yeah, pretty much I did, right? It's there. It tells you what's going on. So we're going to think about it. Is our velocity positive or negative? Negative. We decided that already, didn't we? And then you told me, like, I'm going to go back and double check, so I want to make sure I know. Is it speeding up or slowing down? It's speeding up. The speed on the object is increasing. You told me that. Okay? We put those two things together. I've got negative velocity, and I've got speeding up. Take a look at your sheet. What does that mean? Negative velocity, speeding up. You with me here? Yeah? What does it mean about the acceleration, friends? It's got a negative acceleration. So we said this last week, but sometimes it doesn't sit really well because we have to, like, really get in there and really think about it. If the velocity and the acceleration are in the same direction, that means that something's pushing it further in that direction is going to make it go faster. Whether it's going in the positive direction with a positive acceleration, that's the one we always think of, right? Positive velocity, positive acceleration, going faster, faster, faster. That's driving with your foot on the gas, right? But same thing happens when you've got an object that's falling down and being pulled down. What's it being pulled down by? Gravity! Yeah! We're going to talk about how and why that works in a couple units, but for right now we just know that that's true. We know it speeds up, which means that the acceleration has to be negative. So if you haven't quite processed that, we're going to put that back on our warm-up problem. We're going to go ahead and throw it on there, and you should as well. We're going to make a note that this acceleration is negative. That's a big deal. Big deal. Okay? Look at all of the physics we just did, just filling in one little box. There was a lot of physics that just happened there. I just want to, like, acknowledge that because it's exciting. All right, I want you to take a look at this little velocity versus time graph. Now that we've had this conversation, talk at your tables and sketch a velocity versus time graph on your whiteboard. Okay? That's the only thing I want on there, just so I can see it. You can hold it up and I can do that. And we're just doing the velocity from the time it gets to the time it's released to the time that it gets to the floor. Go, go, go. See, show me your graphs. All right, I'm seeing lots of good stuff, friends. Can you show me? Show me what you got. All right. Okay, you can put it down. All right, so I'm seeing, let's see. I am seeing some, I know it's on freezing, I'll get it off of freezing in just a second. I'm seeing a lot of them that look like this. I'm not saying that's right or wrong, I'm just saying that's what I'm seeing a lot of. Talk to me about, because it was the majority of tables, talk to me about why you would draw a graph that looks like this. What were you thinking? I mean that in a positive way. What caused you to draw a graph that looked like that? Go ahead and get us started. Lizzie, go ahead.
You, like I said before, say that where you're dropping it is zero.
Okay.
You started from zero.
Okay.
That's a negative velocity, and you're going to the negative products. Like you said.
Okay. So I think I understand what you're saying. Although the wording that you're using is talking about its position, right? Does that make sense?
Yeah. Like it's going faster but negative as the time is going on. So you're starting at zero because it hadn't done anything yet, and then you're making it to negative.
Initial velocity 0? Does that make sense to everybody? Yeah? Initial velocity 0? Is that okay? Yeah? And then the speed is getting bigger, more negative, because it's negative, it's going to keep getting more negative. Yep. So the speed, friends, the speed is just the distance from the axis to the point or to the line, right? So the further distance that your line is from the axis, the faster you're going. And if it's negative, it's going backwards or down, and if it's above the axis, if it's positive, then you're going forwards or up. How are we doing? Am I totally just taking exactly what you wanted to say again? That was happening. I feel like we're clones of one another today. How are we doing? Are we okay? Okay. Question for you. I didn't see this one today, but I want to ask you because I want to make sure that you understand. What would this graph be? Is this also an okay graph for that situation? Is this one also showing an acceleration? It is. If it's slowing down or speeding up? It's slowing down. Are you with me there? Is that okay? It has a negative velocity because it's still down here in the negative part, but the velocity is getting closer and closer and closer to 0. And what did you say? Whoa! That's like, yes. The slope here is positive. And hey, I have a question. Pick me. If I have a slope that's positive, what does that mean about the acceleration, friends? The acceleration would be positive. I want a slope that is negative because my acceleration is negative. There it is. It's negative. Yeah? These are good things to write down. I'm going to write a couple of them down, and I want you as well. Woo! Look at that. Okay, so we got that the slope is negative, and we know that because the acceleration is negative. That's a big deal. That's cool. All right. How are we doing? Fantastic. We got one more to do. That position versus time graph. I want you to go ahead and do that. Erase your boards. Talk to your teammates. Draw that acceleration versus, not acceleration, position versus time graph. Sorry about that. Position versus time graph. Make it happen. Fantastic. All right, my friends. Let me see your graphs. Can you show me what you've got? I love physics so much. This is so good, you guys. All right. I love this. Okay, so I see kind of 4 different things really. I'm going to draw all 4 of them for you. If I can remember them. Oh, it's on freeze. I'm sorry. Okay, I've got 4 different options of things that I saw. In no particular order. I have to remember now. I think I saw one like this. I think I saw one like this. I think I saw, wait, put them up one more time. There was one more that I can't remember. Oh my god, oh, it's okay, I remember. Okay, then there was one like this, and then there was one like this. I think these were the 4 that I saw. Okay? So if you haven't been looking at that bright gold sheet, the one that's the bigger, the full-size sheet, that may lead you to the right direction, but let's have a quick conversation. Tell me what you know about the velocity. You know that it is negative, and that it is getting more and more and more negative, right? The values are getting more and more and more negative. And the way we represent that on a position graph is by that, starts with a slope, right? So if the values here are getting more and more and more and more negative, what does that mean about the slope here? It's getting more and more and more and more negative, right? So let's take a look at some slopes here. And friends, I'm not attaching, I just want learning to happen, okay? So again, the values here are getting more negative, and that came from, oops, come on, the fact that you told me the speed was increasing, that it was a negative velocity, right? Just want to make that clear, this is where it's all coming from, okay? The values are getting more negative, which means that over here, the slopes should be getting more negative. Tell me the story of this top graph. What's the story of this graph? It's moving in a positive direction. Tell me about the slope here. The slope is constant. Does that mean it's speeding up, slowing down, or staying the same speed? Same speed. So does that make sense? Have we done this graph before? Yeah, for sure. We did this with the buggies, we did this with the bowling, but we've seen this. Okay, but that's not what we've got in this case, because we've got a change in velocity. All three of these have a change in velocity. Let's take a look. So I've got velocities that go, I'm going to draw some tangent lines here. How are we feeling? Getting more negative. Do any of those get more negative? The slopes get more negative? Yeah? This one does, right? It starts off with a slope of 0. Oh, that's cool, because if the slope is 0, that means that the velocity over here was 0, which is what we wanted, right? The velocity one was up here. More? Okay. Okay. This one gets more negative, but then what happens? Slows down. So this one would match more with a velocity versus time graph that has a negative slope, right? Negative slope, negative slope, negative slope, and then what happens? Like that, right? Okay. How does this top one and this bottom one compare? How do they compare? Quincy, how do those two compare? That I have on the screen right now. This one and this one.
It depends on where you're starting. So if the railing was 0, the floor would be like -5.
Mm-hmm.
But if the railing was 5, the floor was 0, that's the difference.
Yeah, go ahead.
In ours, we just have like a line that like symbolized the ball like stopping. So I think that's maybe what.
Oh, so it's kind of more like this way, wouldn't it? Like that?
Yeah.
Oh, okay, that could make sense. That makes sense to me. That looks really goofy now, and I apologize because I picked the wrong color. But yes, I see. That makes sense. I just wanted to make sure it wasn't like curving, because that curving changes. Thank you for helping me to interpret things. I really appreciate that. These two guys are the same? Is there one that's right and one that's wrong of these two? Nope. It just goes all the way back to the beginning of our conversation, way back up here, where we said, are we calling x equals 0 here, x equals 0 here? That's all it is. They're both correct. Is that okay? Okay. Questions that you have for me? That was quite a warm-up problem. Have you noticed that warm-up problems are really just problems that we work on and that just kind of lead us to physics? Okay. This is what I need for you to do, friends. We are, I had planned to do some of our lab analysis today, but we are not going to do that. We will start with that on Wednesday. Why not tomorrow? Because what are we doing tomorrow? Taking a quiz tomorrow. I just don't want you to forget that. Right now, what I'd like you to do, listen carefully, I'm going to give you 1 minute to erase your boards and put all of that equipment away. Put your other stuff away, and then in a minute, I'm going to grab your attention back so that we can talk about grades. Okay? Hold on just a second, friend. The reason being that I want to make sure before parent-teacher conferences that you feel like you understand what's going on in terms of the grades. Okay? I have to apologize because part of the reason that it's taken me so long to have this conversation with you is that I've been waiting because Canvas has been kind of goofy in terms of how it's been reporting out to you, and I wanted to get all of those things as clarified as I could before I had to talk to you, but now I have to talk to you because I want to make sure that you know it before I talk to your parents about it tomorrow. Okay? So just to be very clear, everything that we're doing is very transparent. I don't want you to think that I'm monkeying with your grade or that I'm doing anything nefarious. The reason that I set this up, I mean, let's be honest, I could just do points, right? Like, that would have been the easy way to go through all this, right? It would have been easy. But I will tell you that after having taught for a long time using points, it feels really yucky to me. It feels like it's not a really honest communication opportunity, and so I wanted to give you this opportunity to hear how it all fits together and to see how it all fits together, okay? So tomorrow you're going to take a quiz over these 3 standards, and after I grade that quiz, I will put them into Canvas just like I did the last quiz, okay? You have access right now, don't pull it out because I just want you to listen for a second. You have access to all of this on Canvas now, okay? If you look in Power School, there is not a grade, and I totally hear that, okay? I will put grades in Power School by midterm and the end of the term, okay? And the reason for that is because I want you to look at Canvas, because Canvas is where everything is represented accurately and where everything is put together in such a way that it makes sense from a standards approach, okay? So I just did some screenshots from some student, I don't even know who, but this is what I see and what you should be able to see for each of your standards, okay? You have to go in there and you have to look at the learning mastery thing, but if you do that, under Unit 1A, you should be able to see a standard that says 1A1, okay? And if you don't know what that is, they're all listed like in the modules on Canvas. They don't allow me to put the whole thing in there. I apologize for that. But this was the graphing, non-accelerating motion. The Buggy Lab had a score for that, and also the quiz had a score for that. So this student got a 9 on the Buggy Lab and a 7 on the quiz, okay? So if you look right over here, you can see that their score on this standard right now is 8.3, okay? That represents the fact that we've got it, but we're not quite there 100%. Remember, 9 is what you're shooting for. 9 is that excellent, right? That means, yes, I've mastered that standard, okay? If you look down here on that second standard, we've only done one thing, and that's the quiz that's gone through that standard. Are there more opportunities to do that? Yes, 100%. Remember that I said earlier today that if you want to do the retake, you can do that this week. You just need to meet with me, talk to me, and we'll make that happen, okay? You'll also have an opportunity on the test that comes up at the end of this unit, as well as on the final. And we'll talk about what the final is going to look like later. I don't want you to stress out about that. I promise that it will be to your advantage, okay? Okay, I'm trying to help you. I'm trying to get you so that you are mastering physics, okay? So that's what each of those standards looks like. And when I transfer this stuff to Power School, I will be using these values, okay? A 9 is an A, and then it kind of goes down from there. I need to verify with my other physics teacher to make sure that we're on the same page, but I'm guessing that about what it's going to be is a 9 would equate to about 95%. A 7 would equate to about 75%, and we can go down from there, okay? So if that grade makes it make sense to you, that's kind of where we're at, okay? But I just want you to know that, again, we're not playing with points. We're playing with shooting for mastery, okay? So I want you to trust me, and I want you to look at the way that you can see progress on here, okay? The lab standards are in there as well. The lab standards, Mrs. Murphy and I have agreed that we're going to adjust this for next trimester so that they're out of 9 so that it doesn't seem goofy. But we had established this before and then printed, I was like, we're learning as we're going, just like you guys are learning physics as you're going, right? We're all working together. To me, a 4 is like a 9, okay? That means you get it. You meet the expectation. A 3 would be like a 7, etc. You can kind of work down from there, okay? And I don't want you to, we're working all out once we've got all those details. So in the L1, that's the design standard. So we got the basketball lab that you did like the second day of school, okay? Then you just did another one, that object fall time one on Friday, or you need to come in and work on that with me, okay? That will be assessed and that will go in here as well, and they just kind of keep going from there. Okay, L2, L3, etc. Okay? So again, the big pieces to take away, you have access to it on Canvas, and that's where you should look. That's how you can find out where you're at, what things you want to reassess or you want to work more on, so that you can show mastery. Okay? I will put things into Power School, but I'm not going to put things into Power School every night or anything like that, because this is where I want you to look. Does that kind of make sense? Okay? I want to talk to your parents about this. I want them to understand. So send them to conferences, or have them send me an email, or give me a call, or come visit me, or anything, okay? I don't want this to be a mystery or scary. I believe in this, and that's why I want to do it. Okay? What questions do you have for me before the bell rings? Yeah?
So if you, like on a test, if you get everything right, you get a 9.
Sure.
Okay. And then you said that translates to a 95.
Okay.
I got
so it's not going to be just from one test, though. So I am only going to put in one score for each standard. So when I put scores in, I'm going to go back to this one so it's easier. I'm not going to put each of these into Power School. I will have 3 or 4 pieces of evidence, and that will give me one score, and that's what's going to go into Power School.
Okay, yeah, but so if you get it right, and like you do everything right on a test,
Uh-huh,
then the standard would be a 9,
yep,
and points would be 100%. Right?
say that again.
So like, if you did everything right, and didn't get everything wrong, and didn't go above and beyond, you get 100% on the test.
But I'm not doing points, and I get what you're saying, I see where you're going with this, but if you get 9s on everything, you will get an A.
But doesn't that limit your room to get an A by half? Because if you get everything right, then you have a 95 instead of 100. And so then 95 to 100.
But if you get all 9s, then you're gonna get a 95%.
I know.
I understand what you're saying, but it's the process of playing school versus mastering physics. And I want you to get the standards and not play to get points. Does that make sense? It's a shift, I totally understand. And you guys have been programmed, and I have been programmed for a long time to just try and figure out how to get my points so that I can get my score where I want it to be. But I want you to shift your thinking, and I'm doing the same, to say, I want you to show me that you know physics, and once you do that, it's all good. Because on your transcript and whatever goes to college and all that is just a letter grade, right? There isn't a percentage there, okay? It also gives you a little bit of wiggle room for that 10, right? That going above and beyond. Not saying you have to, but so that I can document and acknowledge that approach as well. Does that make sense? I totally get what you're saying, but I think it's a shift.
Like when there's only, like in like the letter grade system, when there's only 5 points, and then you go, so like let's say you usually get 7s, or no, you usually get 9s, because then that'd be in the 90 to 95 range.
Yep, yep.
7 range, you got 100.
Yes, and so I was thinking, can I say this to everybody real quick before you go? Because I appreciate that question. As the term goes, if there's something where you feel like it's not correctly reflecting your understanding, then we should have a conversation. Does that make sense? And I'm super open. Does that work? Awesome. Thank you guys so much. Have an awesome day. Hey, yo, what?